Hello. Let's see. Hola, hola. 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 Hola, 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 hola. Probando. Hola. 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 Hello. It's okay? Are you listening to me? Okay. Thank you, Juan Pablo, for introduction. Well, I'm going to first, good afternoon for everybody. I'm going to address two things. One is, like Juan Pablo said, how we are working in AA, in Antel, and also then I'm going to talk about one of our first project in AA, that is AI, sorry, that is mobile phones recommender systems. One thing that I will try to say is that Antel is a very big company, and we have a lot of amount of data and variety of data. So it gives us the opportunity to start working with all of AI applications and services. And also before, we have the big data platform. We have a lot of problems because we have all the data spread for all of the company, and we have difficult to work with that data. So after we have the big data platform, it was very easy to have all data. It was very important to have all data in one place, and we have to start working very easy with try to build these AI applications. So how Antel is trying to introduce AI, and we are following some advices from the landing AI. So one thing that we are doing is like collecting data from every system of Antel, like our legacy systems, mobile applications, web applications, the telco network, APIs, IoT, everything. Every data set is welcome, and every data set is going to the data lake. So we want that all data goes to one place. Then we built an AI in-house team and empower that, and we are working to enhance that team. We built some short projects to get momentum into organization experience. This project is better that to be successful than have great impact into the organization, because we have to do it quickly. That project should last at least 5 or 10 months. So then we can start working on bigger projects that have more impact on the organization. Other thing that is very important is provide broad AI training for all the organization, not only for the technicians, but also for the managers or the stakeholders or sponsors, because AI is a great opportunity that touch all the organization. So it's very important to give training for everyone. So that team that we built is now in teaching courses for all the co-workers, that they can start working right away. And also we are trying to develop like a course that it could be taken by the managers and by the stakeholders, so as they can take decisions on AI. Also, we have developed an AI strategy, and we are taking it right away. We have we want to take advantage of the benefit of AI. So we have to improve our products and our services, and that is very important that the company strategy is aligned with the AI life cycles. And also, even more important, to develop a data strategy and then align the company strategy to that data strategy. And also, we have internal and external communications. Internal communications is very important to give our co-workers and all the company confidence, culture. And then we have also external communication for have good visibility with our users and customers. Some of the AI projects that we have completed, some of the ones that we want to gain some momentum, was a mobile phone recommender system. That is a mobile phone recommender system for retail. We are going to talk a bit deeper in a while. We also have debt risk prediction. That is, we want to predict if a customer will be indebted in the following months. Then we have a fleet tracking traffic solution from IoT that is try to detect anomalies in the fleet tracking traffic solution from IoT data. So we also have many projects in progress. Some of them are very specific from the telco companies, like network optimization and operation. And for example, the predictive maintenance of network elements. That is, we want to predict if equipment will be failed and try to do some preventive task. And we have telco network failures and detect anomalies. That is, maybe we want to predict if a service will fail, or congestion, or detect any kind of anomalies. We have also, in the area of user experience, recommendation of shows and video on demand recommendations for our application like Antel and Vera. In the area of marketing and sales, we have customer segmentation. We want to improve our knowledge about the behavior of our customers and try to bring them better products and try to make targeted marketing and also get better campaigns. Then we have price and performance optimization. We want to get some kind of machine learning algorithm to get better performance on price optimization. Then on fraud detection, we can try to predict if some hacking on the centrals to make free calls, for example. Then we have radio astronomy. Antel is promoting radio astronomy in Uruguay, and there's a project ongoing with the academy that is very interesting. And the project tries to convert a 32 meters antenna, dish antenna, into a radio telescope. That radio telescope can achieve and try to find every sky, and in the sky it can get a lot of big data, and we can try to apply machine learning algorithms, like try to identify exoplanets, for example. Okay, now I want to talk about one of the first projects that we have done in the company. We try to incorporate with AI, that is a Markov chain clustering mobile phone recommendation system. We want to share experience of what we have done. This is one of the first projects so that the main objective is that the organization adopted it. So we put a general objective, and then we try to be more specific. And what we want to do is giving a user and his mobile service number, and give him or her a recommendation set of mobile phones that may be interesting to him or her. In one word, what we want to do is try to give recommendations that will be useful for the user. So we start studying different kind of learning algorithms for recommendations, and it was an endless task because it's a wide area of research. So the most common algorithms are content-based filtering, like if user read an article, you can recommend to him similar articles, or collaborative filtering, that you have similar users that read some articles, you can recommend to others as users similar to them, the same articles. And these algorithms are very popular, but we didn't use any of them. Why? That was because we follow an approach with some principles. The first principle is, based on our data, choose the model and not vice versa. We don't want to fit our data to the model. We want the other way around. So in the case of collaborative filtering, that's very popular. In most of cases, you utilize the rating, the user ratings of the product, and we don't have user ratings. So we've tried to find an approach. Then in second place, we want to build a data product within 6 or 8 months. This is very important for us. We want a recommendation system in production. Then in third place, we want a simple and scalable model. This is very important because we want to achieve in 6 or 8 months. So we have to do something simple and scalable because we have to think in the whole production pipeline and maintenance. Then the fourth, focus on data we have. Don't waste time to find more data. That is because we know that finding more data is a time-consuming task. So we don't more, even more if you want to ask to someone else for this data. So we want to do something simple. Then we need usability, because we know that when we put the recommendation system in production, managers will come and ask why we're recommending that, why a user that use iPhone will recommend something else. We know that we have that questions, and we want to explain that. So if you want to base our algorithm in our data, what is the data we have? This is an example of a data set we manage. We have in the first two columns the user identification, and the second two columns we have the mobile phone identification. The last one is the date that I start using this phone, and the middle one is how many days is using the phone since this date. So with this data, we start to try to find some intuition and see what you can do. So we think that we want to recommend a set of mobile phone to a specific user, knowing the users of actual mobile phone. So why not see what other users do with the same mobile phone? Which new phones they bought after? In one word, we can think that maybe other users get through the same situation as the user we want to recommend, and we want to recommend maybe the majority of phones that others change. So we have the user's historic data about the mobile phones transitions, so we can model the mobile phones as user possible states. Then we can calculate the probability to transition from one mobile phone to another. This is known as Markov chain recommendation systems. That was what we like to use in this case. So the representation is, we have states, and the states are the different mobile phones, and transition represent moving from one state to another. Okay, after we choose what we want to do, we're still doing some exploratory analysis, and we find that we have to filter some transitions. What we have is transitions the user from one phone to another. So we would like to filter some phones that used by very few users, because that's no sense for us to use the transitions. Also, we want to filter transition from companies, because we want to recommend only for users, for the end users. So the transitions that involves phones from companies, we don't want it. And the last one that was important, it was that we have a lot of transition with few days of usage. That means that some people broke down their phone, and then they switch to a provisory phone for a few days, and then change again to the previous or a new one. So we have a lot of transition that make noise in our training data, so we want to filter them. It was this one. We have a lot of mobile phones in the network. Then we pass from 28,000 to 5,000. And also, we reduce the transitions. So how do we train the model? We build a square matrix. The dimension is the mobile phones. So we have to initialize all the entries in 0, and then we have to populate the matrix. We calculate for each client, for each customer, their history, change in mobile phones. So we establish a cutoff date, and from that date, we start to count the transitions. So for this customer 1, we have transition from A to 1. We put it here. Customer 2, we have transition from A to B, and put it here. We have 2. And then customer 3, we have transition from A to C, put it here. And D to A, we don't put it because we don't consider involutions. We don't care about involutions, because sometimes happens that some user broke down their phone and he can't afford for a new one. So maybe it returns to the previous phone. So involution is something that we don't want to care at this moment. So after we have all the matrix trained, we call the training to populate this matrix. So after that, we have the recommendation set. If we want to bring a recommendation for the model A, what we do is to pick this row and order it in descending order. So we have to sort it in descending order, and then we pick the top case states that will be the mobile phones in the recommendation. Key is the number of recommendation in the recommendation set. It's kind of a parameter hyperparameter in our model. After we have this model, we want to try to experiment with another one. That is, use the same model, Markov chain model, but combine it with clustering. So we consume an API and get all the Antel mobile phones and get the features. Then we keep only the ones that is important for us, like brand, model, operating system, cameras, pixels, screen size, camera resolution, memory size. And we build a clustering with that. We try to explore different techniques and different distance. Then we have the clustering. What do we want to do? Make another model. We have to combine Markov model and clustering. The thing is how we build the recommendation set. What we do now, instead of picking the top K from this row, we pick the first one, that is more relevant, and put in recommendation set. Then we pick 2 from a cluster, and put it here. Then we pick C, that is the second, and put in recommendation set, and then we choose 2 similar from cluster. We can play with the quantity of recommendations comes from cluster or come from the matrix. So the intuition here is try to see if maybe recommendations from cluster are better from the Markov, because sometimes Markov, we can, with this recommendation, we can get maybe the first 2 that has high probability, but the others maybe are very low or even 0. So they are not good quality recommendations. It's just an experiment. And then we have a constraint here that recommendations from cluster are bounded to Antel mobile phones offer. So here in the cluster only have the telephones that Antel sell. That is 40, about 40. And we have 5,000 mobile phones in the market. So after we have the 2 models, how do we validate them? If this is the data, we have a cutoff date and leave this part for the validation set. And we train with this, and we put another cutoff date here. So we train in a window period. I will tell you in a few moments why. And then what we do is we stand in the previous telephone of the customer and try to recommend here and try to predict if the next model, phone model, is in the recommendation set. So we try to predict here to see how well is the recommendation system. I mean, if the B is in the recommendation set, we score 1, otherwise 0. And this cutoff date is the same as this one. So we have this validation and the results. We train the model for several, but we resume here the results for 4 months, 8 months, and 2 years training window. And we give a recommendation set of 1, 2 recommendations, 6 recommendations, and 10 recommendations. More than 10 recommendations is not meaning. It has no sense because we have a very slow offer. So if I increase the quantity of recommendations I have, it's obvious that I'm going to get better score. But here is something interesting, that is time factor plays an important role because we have more score when we train for 4 months. So what turns out is that the mobile phone market change every day, change so much. So if we train with 2 years, we are getting old transitions, very old transitions, and then the recommendation will be also old, so I will miss then the prediction. So we also compare the 2 models, that is Markov and clustering combined, and we see that introduced clustering didn't improve Markov pure models results. Why? Well, we think that the cluster is very, very small, and we don't have enough recommendations to take from there. So this model was better, so we keep with this one. And we are very happy because we went into production with this one, with the recommendation system. So now we found our objective that it was not only make a model, also to put it in the organization, try to convince others that we can try to put it in production. And then we see some conclusions. First, we have 27% of accuracy in predictions. For us, it's acceptable for recommendation system, random prediction, because we have a lot of classes here. This is the number of mobile phones in the market. It's very slow, very tiny. Then time factor plays an important role. We have also seen this. We have a cold start problem like every recommendation system, because every time a new model comes to the market, we don't have enough transitions to give a good recommendation. But to address this problem, we use the clustering, the same clustering we try to use to combine the combined model, we use to address this issue. Then this is very interesting also, when you try to validate with the other notice in Antel, we have that everyone says to us, I have a user that has iPhone and you are recommending other phones like Huawei or others. You should doing something wrong, so go back and see what we are doing. And we go to the code and see the data, and we see that this is happening now. Some iPhone users are changing their phones, more even the users that have iPhone 6, that is our old model of. Then, this is also important that get a good business feedback, because all the recommendations we record, we can tell Antel that some of the top recommended phones, maybe Antel is not selling them, so we can tell Antel that there are a lot of recommended phones that he should buy and recommend for. Then we have to establish some of the measures that we need in production, because in production is different. Maybe we can measure the accuracy and recommendation after user change the mobile phone. We can measure sales increase on recommended mobile phones. We can also measure recommendation item clicks. After we have this measure and we want to change the model in production, maybe we can perform a kind of A/B testing to see which model is better, and try to publish B to some users and then see what happens. If it's okay, we publish to all of them. If not, we have to roll back. Last slide. Future work. We can extend the clustering for all phones and improve the combined model. We can do that if we can find the data. Also, if you have this, we can also change the Markov model and try to use state as clusters instead of mobile phones, so we can calculate the probability to go from one state to other. And last one, maybe we can use reinforcement learning. One more sentence I have to say is very thank you for the organizers of Khipu. I can never imagine that such an event can take place in Uruguay and Latam with outstanding speakers, and thank you to them to participate. Thank you very much.
Okay. Maybe we have time for one quick question. If someone has a question. I guess that's it. Let's think.